Hi, my name is Tomas, and I am very excited to be chosen for the Bergen County Teacher of the Year for the 26-27 school year. I am a teacher at Northern Valley Regional High School at Old Japan, and that is located within the Northern Valley Regional High School School District. This year, I teach chemistry to 10th graders, and I teach 3 different levels of chemistry. I teach an honors chemistry level, a general chemistry level with an in-class support teacher, and the class that you'll be seeing today is for my college prepped enriched chemistry class. During the lesson today, the students will determine the relationship between pressure and volume for gases. In order to do this, they will be working collaboratively in groups, and they will also be using digital wireless pressure sensors to help them collect all of their measurements. In order for students to be successful in this experiment, I built a hybrid custom lab. This enables students to visualize the particle motion, provides directions to them, allows me to monitor student progress on the teacher dashboard, and it also records the measurements from pressure sensors for the students. This dual approach of digital scaffolding and physical hardware ensures that all of my students have the tools to thrive in my chemistry classroom. Prior to this lesson, students learned about kinetic molecular theory and how that relates to the particle motion of gases. In this lesson, they learned the relationship between pressure and volume, and then for follow-up lessons, I will introduce new variables, such as the amount of gas and temperature. I will also introduce new equations, such as gas stoichiometry and the ideal gas law. This will culminate in a real-world engineering challenge where students have to mix different amounts of chemicals in order to create and design their own airbags. The primary lesson objective for the lesson was for students to experimentally determine the relationship between pressure and volume. I am pleased to report 100% of my students have achieved this lesson objective. I was able to verify this through the custom dashboard on radiansims.com that I have created. As you can see, I collected data on not only if the students answered the questions correctly, but which students took multiple attempts to answer and how much time the students spent on it. I also have data on what the common misconceptions are in order to follow up on these in future lessons. Overall, the lesson went incredibly well, but there's one change I need to make to ensure it goes better. Some of my students used a short tube and got really good results, and other students used a longer tube and got worse results. This is because there's a lot of air in here compared to the shorter tube, and that threw off the measurements when it came to measuring the amount of pressure and volume for the different sensors. So in order to fix this issue and improve the lesson for next time, I will give all my students a short, uniform length of tube in order to ensure they get better results. And then hit record. Now you can screw it back in, and then Colin can start reading you the procedure.
Yeah. All right. Next one is what, 55?
Do you what?
All right. This is
Yeah, fill out the data tables when you do that. When you get that far.
50.
Scroll to the top. You have to confirm it's set up, and then you get next.
Do we do it twice?
Yeah, literally the same exact procedure twice.
45.
Did you check your data to make sure it was good? Make sure your numbers make sense? Yeah, that's all.
What was that? All right. Next one. What do we got? 40.
Nico, don't put in the KPAs. I'm not sure if that's going to let you check the data. So just the numbers, okay?
All right. Next one. What do we have?
You girls doing good? Okay. Yeah, so you're getting some good numbers. Excellent job. Okay, maybe you should read it once she's holding it there, and then later you could type it in.
Okay, a little harder than I thought it'd be.
You could check data, just make sure you're getting numbers that make sense also. Okay.
Got 182. If I could keep it at 30 for a constant pace, that would be beautiful.
It would be.
Yep. 182.4.
All right.
How's that?
It is. You have to hold it down there and then have the other person read it off.
It looks like there's a big increase in pressure, and it looks like it's.
Yeah, if it's a little bit off, don't worry about it. It's going to mark it right when you hit check data.
Should we redo 30?
Let's redo 35.
Yeah, redo 35. Michelle, I was marking some of our calculations wrong right here.
Some of your what?
It was marking some of them are orange.
Try and redo those. Were you holding it down for that temperature for sure?
Yeah.
Yeah.
Let me see.
So what are we getting for 35?
161.
161.6, and then try 30 again. We're getting 183.2. Ooh. Or I'll put 0.4.
You know what I think is happening? You have like a long tube with lots of air in it. So it's like, just go a little bit further. Go like 2 or 3 more for each one, then it should be marking the right.
All
Because you have more air in here, and I think that's what's throwing you off.
All
Okay.
right.
So do like 32.27 instead. Okay.
You think you can do it? Yeah.
We're going further back. So.
157.5.
Any questions, boys?
Jesus.
Okay, cool.
57.5. And then 30.
32.
It could be some air escaped, but it's more likely it's just a little bit off. Like you're not the exact same points as before.
Oh, okay. You know what? This is really nice.
Oh, good. Your girl's almost done. Just one more try.
Do it again.
Guess we'll do it again. Oh, you have to go higher. So like 2 more.
He said.
No, like 2 more notches. So like if we wanted to go to 35, go up to 30.
Yeah, go to like 32 or something,
Yeah.
and then.
Oh, you mean?
Yeah, and then for 30, go to like 27.
To 20.
Because the air in the tube's throwing you off a little bit.
Yeah. So
Yeah, 198. That works.
Okay.
I just saw it before you moved it.
All right. Beautiful. Thank you.
Yep.
198. All right. So now we do this one. All right. Hold on. Just fill this in. I'll just do it real quick. So 40. We have 156.
Schools do not exist within a vacuum. They exist within our local communities. As teachers, we must create connections to deepen these ties in order to make learning more meaningful for our students. I do this by bringing the community into my classroom and by connecting content to the students' daily lives. One way that I bring the community into the classroom is by having guest speakers. I have guest speakers come in at several different points over the school year, and they cover a variety of topics such as nuclear power plants, the solar industry, and careers in chemistry. Another way I bring the community into my classroom is by hosting an annual Slime Time activity on Take Your Child to Work Day. My high school students become experts and explain how to safely conduct a laboratory experiment to make slime from a variety of chemicals. This leadership experience leads to increased confidence in their abilities, and the students realize that to teach a concept is to master it. For the community, it creates scientific curiosity from a young age, showing that science is both fun and accessible. Another way that I connect my classroom to the community is by physically bringing my students from the classroom into the local high school campus. I do this during the environmental science unit, and the students go around campus and use geographical information systems to plot where they are and what kind of surface they are on, such as grass, turf, or pavement, and use digital temperature sensors to see the effect that these different surfaces have on the microclimates of that area. This allows them to analyze the data, which eventually leads to a project where they could use this information to help build more sustainable communities and keep heat island effects to a minimum. In conclusion, for learning to be more meaningful, it must be connected to students' daily lives. By fostering these connections, I ensure that all students leave my classrooms, not just with content knowledge, but stronger connections to their local communities. Thank you very much for considering my application.